And this is the Zoom for Heavy Civil, Thursday, April 16th, 2020. So we just covered that there will be a masonry test next week, probably the end of the week. We'll decide this coming Monday at our next Zoom, which is 7:45 p.m. after surveying, and we'll decide what day the test will actually be on. It'll be later on in the week. We'll talk more Monday night about the time frame, because these tests are timed and you're not allowed to go back to a certain question. So once you give an answer, you're done. But we'll go over the game plan on Monday night. I'll record that if folks cannot attend that Zoom on Monday. Okay, it'll just be on masonry, nothing else. And then the last test will be just on soils, which we will start next week. Okay, so the estimating that we had you do is has been graded, posted to Vanco, and then I have posted the answers on. Here's the answers that I posted for you. Okay, and I'm going to give you a drawing. You're going to have to find. You're going to have to estimate block. So you can use either the course method, or you can use the area method. This was actually a little bit of both.
I have a question.
Yeah.
So on this, were you including the doors or not including the doors in total wall length? Like I got 64 feet 4 inches, not 81 feet 0.33.
Yeah, this is the total length of wall.
Okay, so including the doors.
Yep.
All right.
Yep. Because the doors are within the wall, and then eventually what you're going to do is you're going to combine all the doors together when you're dealing with the area, the surface area, the face area, if you will, of the openings. Okay. But it was critical that you got to get those. You got to get the total length of wall correct. Otherwise, none of the numbers will make sense. So we broke it out last week where we talked about the 3 courses of bond beams. We had 15 courses of the regular stretchers, and then we had 1 course in green of the 4-inch solid. It's like a cap. And we're going to show you some pictures in a PowerPoint. We're going to show you some pictures of Catskill Hall, ET. I don't know if I'll get to the field house photographs, and that'll help you study for the test. A lot of the test is going to be on identification. You've got to be able to identify the components of a block wall. And then you'll also get into a little bit of estimating. And don't forget to just kind of review those specification homework questions, because that'll be on it as well. Very basic. So in essence, because you're home, it's an open book test, okay? And we'll go from there. So we got that, and then we got the gross area as if the doors and windows did not exist. Okay, and we were getting just the gross surface area of the stretchers, the bond beams, and again, the 4-inch solid. Really, the 4-inch solid, you could have realized that it was not in an opening, and you could have just used the course method. Okay, and the course method is 81 feet, and for every 4 feet, there are for every 4 feet, there's 3 blocks. So if you take that number, multiply it by 0.75, which is 3/4, you got your answer. So again, there's we've gone over some of the methods, the area method, and then of course the course method. Here we got the gross areas, and we had the openings. within the opening, you've got to find where the door fits in that cross section. And if the door is 7 foot 4 inches high from here, that's 7.33. We know it's 8 feet total from here all the way up to here. 8 foot less 1 block is 7 foot 4. And that makes sense that that bond beam becomes the lintel. Okay. And I'm wondering if I have chapter 25. So chapter 25, there's your bond beam. So that bond beam is your lintel. Okay. And then we had the opening areas, right? And then the net area, and then this, you will be given this conversion factor. I'm not going to make you memorize that. 1.125 block for every square foot of wall surface. So we take that square footage, which is the net area, the gross area minus the area of the openings. Take that, multiply it by 1.125, and that's the ballpark that you should be in for the number of stretchers. And again, 8-inch block, when you order it by the cube. I think there's like a 108 block in a cube. And every third block is a corner block. Okay, so these regulars also include the corners. The bond beams, net area times 1.125, boom, 171. And then the solids was 62. The one thing I didn't go over that I put on the on here is all you got to do is get the net total area, the net area. Okay. And then there's the total gross area minus the opening area, and you multiply that by 0.06 cubic feet of mud. That's going to give you 55 cubic feet. And a couple of you, and I'm going to put this on the test. I'm telling you right now, you can tell me that it's concrete, but you had 55 cubic feet. You had 55 cubic feet and you multiplied it by 27. So what you did was you gave yourself 1,500 cubic yards of mortar instead of 2. So that is fair game on the test.
So you only go with one wall there, with the 12, 6, 7. You don't take like the possibility of all 4 walls? Because I noticed where I went off was I took all 4 walls. I multiplied the for the total wall height, that 12.67 on top. Yep. And I multiplied that by 4 and then started running the stuff out. That's where I had gone off there.
But that's your total linear feet, which includes your 4 walls.
Gotcha.
By getting the total linear feet, you're able to use that throughout the entire problem.
All righty.
Concerned about is that a lot of you got 55 cubic feet right. Okay, you got that right. But instead of dividing by 27 to get cubic yards, you multiplied by 27. Okay, that's a cardinal sin. I got to watch what I say because I'm recording. I don't want to get in trouble. Separation of church and state, but that's a bad one. Okay, you make that mistake, you're not going to look good out in industry. So I say that to help you, not to criticize you. And trust me, like I said, I ordered an extra truck once, so I know the feeling. You don't want to get that feeling. So go through these steps. Try to walk through this the answers step by step, and we're going to throw some block estimating on the on that test. Okay. So
Is the time given for the test going to be the same as the time we'd have in class?
I have no idea, to be honest with you. I've never done one online, so I'm going to talk to probably the test master, Mr. H, and he will give me good guidance on what is fair, and then we'll go over the ground rules on Monday night.
Okay.
I don't really know. And the other thing is, with that, some of you are working, so I'm not going to say that the test is, say, Wednesday from 9 to 10. I'm probably going to run it at night. Okay, so think about, I'm going to throw out some options Monday night as we discuss the test parameters, and we're going to agree on a time that you can sit down and take this test. Okay, everybody's got to sign off that you can take the test in the time that we're going to decide. Okay, and like I said, it's probably going to be an evening, and it could even be next weekend. It really doesn't matter to me. It's whatever's easiest for everybody's got to be able to take the test at the same time. And like I said, I don't know if the test is open for 2 hours. I'm gonna give you at least 2 hours, but just remember you cannot go back on once you answer a question, you can't go back. So let me check my. I was going to do that, and then I got a little PowerPoint for you. We've talked about the masonry exam. So this PowerPoint is on. It's on Vanco, and that is right here on the week of 13 to 19 April. It's CMU ET and Skill Hall. So that's yours. There's one thing I'm going to add to it. So write this down here in a couple of minutes. So let's go to, all this stuff is in my way. Slideshow from the beginning. So this is, also let me know if anybody's in the waiting room. Okay. I haven't seen anybody yet. So what wall is this on ET? It's closest to what building?
The road?
No. Well, it could be part of it, but no. This is the wall. The refrigeration building is parallel to this wall.
Okay, the walkway.
That 18-foot high, 17-foot high wall that we've talked about with all the formwork. These are all the interior footings. These are all the dowels that are going to go into the block walls, because in that ground floor with all the labs, they're all block walls. And this is actually the elevator shaft right here. Okay. All of these are conduits, because all of the what we call rough ins, the electrical, the MEP, mechanical, electrical, plumbing, have to be installed before you place the concrete slab. So here's some waste piping, electrical conduit, and so on. Okay. Oh. And this is the switchgear room. I don't have a picture of the, this is a block wall. You can see all of these have to go inside the hollow cores of the block. And what they did is they put in a rough opening for the door. Okay. Actually, no, they had the door frame, and they put that in place. And you can see that in chapters 24 or 25 and 26 in the textbook, the door frames that they use. And when the switchgear showed up, right, which is kind of the all the power, the cutoff power in the building, the switchgear unit was so big they had to tear the door out because the door wasn't big enough. So that's a lot of the coordination that has to go on between the trades. This is the front of the building near the curve. Again, you can see the interior footings, and these are all block walls. All these dowels are coming up for the block walls. And there they are starting the block walls. This one's interesting. The slab right here, is here. over here is actually lower, okay? So this is actually a 12-inch block. At the top of that 12-inch block is close to the top of that slab. Again, here's some of the piping that has to go in. That one's got a little issue right there. These are the dowels for the slab pours. One is typically greased so that they can contract this way, what we call laterally. And then this right here is like it's a bond breaker. It's like almost like a thick piece of cardboard that's impregnated with asphalt. And so the slab cannot bond to that block. So remember the top of this block. You're going to see this in the next photo. So the top of that block I just showed you is the top of this block. Kind of an unusual design, but that's what they did. So again, the top of this block is the top of this block. There's the door frame that they used. This is the mechanical room where the boilers are. This is the outside of the building. What do you got here? That's a temporary shore, right? Temporary planking for the bond beam. Okay, it looks like it's got a little bow in it because it's not that rugged. It's actually it'd be like a 2x8, only we call it an 8x2 because it's lying flat. These blocks are just used to hold this shoring up. And then eventually the windows go in. This is all what? What's this stuff? This is all flashing. Now we haven't talked about that, but you will see it on the test. There is moisture that gets behind the brick. Eventually you'll see brick here. There's an air gap between the back of the brick, the back of this brick, and the front of that block. There's an air gap. So this flashing will catch any moisture that gets into that air gap. And there's little weep holes down along the bottom here that'll weep out. This is what you're going to build next semester, God willing, and the creek don't rise, for the Lab 10 mock-up for ET. Okay. So again, there's the door frame. So imagine in that switchgear room, they put in that door frame, and then the damn door frame, the door opening was too small. Literally had to tear it out because the switchgear could not be broken down into smaller pieces. There's a good shot of, there's the bump out. Remember that bump out that you folks built on the mock-up of the foundation wall? See that bump out right there? And then there was one on the other side. That's the bump out. So here again, you've got block backup wall, insulation, a lot of air gaps in there. And then there's also a bump out of 4-inch block, which is a backup to the brick. These are jumbo bricks, 4x4x12s. Okay. Here's inside of the lab. We'll give you a tour of the lab next semester. It's kind of in the bathtub area, and this is how they literally wrap the block around all this big structural steel.
Could have given me a warning. It was like 30 pages. I hit print without realizing.
What's 30 pages?
This PDF.
What'd you do, print it already?
Yeah.
Whoops.
I had to go. I got the pop-up saying the printer's empty, so I had to go run and refill it.
Sorry about that. A lot of pictures.
Yeah.
And then you can see the brick in the background, and that's the front of the building. This is kind of a neat part. This is that wall that you saw from the inside, that 18-foot high wall. Look at this is called a wash. It's kind of where the ground is going to be, so that's more for looks, and so water doesn't collect. But these are all steps, and they're brick shelves. You imagine forming that out? That was an expensive little foundation. This is column line 8. It is the column line closest to the road that wraps around this building and around the campus. So remember this little area right here. It's this area right here. So now you're starting to see the structural steel go up. This would be a neat little one to build.
What's the purpose behind doing the steps like that? Like, what's that going to improve?
It all looks, because you have your backfill, and then you want your brick. You don't want your brick, say, to always be at this height, because then you got all this exposed concrete. So they're literally stepping the brick with the wall, and then this wash is just for looks. This is back when New York State had it was better economic times. We'll just leave it at that. But it's a neat little sequence of photos from that same part of the building. There it is again, that little corner with the structural steel. This is a steel angle. You're going to see this later. This right here is a brick shelf in the concrete. There's some snap ties that they haven't broken off yet, but these are the brick shelves in concrete. This is a steel angle that is welded to this beam, and that holds up the brick.
Not straight though.
No, well, they haven't plumbed everything yet. Plus, don't forget who the photographer was.
Yeah, you can just see this connection of it to the steel. That's not 90 degree,
Yeah.
even with the bend in it.
And there's that same angle that you just saw right there. So this angle right here is that angle right there. And then there's another beam that wraps around, and it has an angle attached to it. And that's, so the brick sits on the concrete right here, comes up underneath this. This is called that soft joint that I was telling you about, so that the brick could expand. And then a new row, a new course of brick starts on the steel angle. This is the flashing. You can tell that they weren't too picky about the block, because the block is not going to be exposed. Could have looked a little nicer than that. Okay. This is all the flashing. They actually stepped the flashing. And there's those two angles that I was telling you about. So that beam right there is that beam, is that beam, it's that right there. And there's the shelf built into the concrete foundation wall. The brick is sitting on that. It's hard to see. Let's see here. Can I see them? Yeah, we'll get to it on the next slide. What's green stuff? You might want to remember that. Ooh, I shouldn't have said that. That is called mortar net. So if they're, or not if, but when they are laying brick and mortar gets in that air gap, if you plug it solid, it's going to be a bridge for water to connect from the brick to the block and then eventually inside the building. So that catches what we call, the technical term is snot. Sorry about that. But it's the mortar droppings. And so water has a chance to kind of meander its way around this. It's almost like plastic honeycombing. Okay.
It's creating channels.
Exactly. Exactly. And it's called mortar net, as in fishnet. Okay. And then you see these little, it's like two little eyelets right here. That is it's called Durawall. It's also called horizontal joint reinforcing. And you want to find that in the Meta book, chapters 25 and 26. There's a good shot of the knockout bond beam, open web bond beam. The joint reinforcement right here, folks, it's like a wire lath. I know where it was. It was in the other one. Let me go back to chapter 25. There's a horizontal joint reinforcement. And there was a picture of it. Where the hell is it here? Bear with me. Oh, of course, I can't find it now. Here it is. So this is the joint reinforcement. So imagine that on the end of this wire are two eyelets that will bridge from the face of the block to the middle of the brick, and they become the brick ties. So there's a strap that has that hooks into these two eyelets, and the strap is mudded into the bed joint of the brick as it gets up to this level. Okay, so that's horizontal joint reinforcement combined with a brick tie. And so this is why you want to get into the Meta books, chapters 25 and 26. Gives some good good shots. A lot of good pictures. Okay. Now, this down below, the backup, the brick is called the curtain wall. You're going to see a lot of this next semester. The block is called the backup wall. But once you get up to this floor level, they stopped using block. Down below here is the laboratory, so they want beefier walls, if you will, for a hands-on construction lab. Up here, they're offices. So now it becomes a steel stud with an exterior grade sheetrock screwed to this face of the steel studs. And then those same kind of brick ties tie in with the brick as the brick starts coming up the wall. And that's what you're actually going to work on next semester. This is a part of the inner part of the wall. Well, there's a good shot of a corner with the bump out. So you got the brick bump out, you got the block bump out, there we go. And then the backup wall behind that are the steel studs, which you can't see. And this is the exterior grade sheetrock that I was telling you about. These are the wall ties. And they have like a strap that fits in this little groove, and it's mudded into this bed joint, and it gives lateral support side to side for the block.
You sure that's not an insulation on top of that sheetrock?
Well, there might be some, I'm sure there might be a little bit of insulation,
It
right?
looks like a half inch. Yeah, it's like half inch.
But this is the extra
glass back.
sheetrock that's screwed back to the steel studs. So there might be some in there. I'd have to look at the detail. There's your corrugated metal decking. These are called stud shear connectors. And if this thing is concreted in, then this gives it more load carrying capability. It looks like a bolt that's been welded to the top flange of the beam. What's this right here? That'd be a good test question. And you laid them out in surveying in lab. That's your 6x6 column. Yep. That's your 6x6 column. There's the flashing. Remember the flashing that we saw originally? The brick was not up. So the flashing comes down and it goes into the mud joint. It really should come all the way out to the face of the brick. We'll show you that next semester. The fact that there's a little lip, see that little lip of the concrete wall? That's where they got their concrete wall out of line and out of tolerance. This wall right here should be flush with this wall. Okay, now there's a little bump out there, so that might be the reason. I can't remember, it's been so long. Hey, we got about 3-4 inches of snow up here last night, so we got that going for us. Looks like a little bit of snow there in the background. There's
Snowing every day.
There's your exterior grade sheetrock. Here's where they wrap a column. You'll see that in the Meta book. Okay, comes in 2 pieces. Here's the strap anchor that is attached to this. This little piece is welded to the column. And so that's mudded into the joint. And then you're going to get another wall running this way that looks like this. So this is looking up. Ground floor is down here. I'm looking up to the underside of the 2nd floor beam. And Meta book. Just going through this real quick. Like right here, see where it's split? So you can have your column in the middle. It's very similar to what we just showed you. Okay. Now what they did here, here's what's known as here's the door frame. Sometimes they call it a door buck. And this little piece right here is a telescoping brace. So they're bracing to the wall. But they wanted to get this wall done. They must not have had the door frame on site. So they did what's known as a sawtooth pattern so that they could get most of the wall in here. Then once the door comes in, then they finish off the rest of that opening. Okay, so that's the door frame that we were talking about earlier, similar to the one that was in the switchgear room. It's like switchgear is like your big breaker, and it's really big. Okay, that looks like that is an insert that's going to be embedded in a bond beam, and they weren't. They didn't have their final position. This was at a job down in D.C. that we went to years ago. Again, Washington, D.C. trip in the fall, September 10th through the 13th. We stay at the Hotel Harrington down in Washington, D.C. at 11 and E Streets. Hopefully we can go. Okay, a little bit of Catskill Hall. And this is the actual mock-up that was done with Catskill Hall. So the contractor had to generate that and show a door opening and then show all the different types of brick. This is actually clay block. This is clay masonry. This is concrete masonry in the back. You've got your flashing, your insulation. And so on the building itself, so this end right here would be, say, over here on Catskill. Here you've got the block bearing walls. So the only structural steel in that building is an occasional beam for openings. It's mainly load-bearing concrete walls. But in the front, see the front here, there's your steel stud and exterior grade sheetrock. What's this right here? That's all flashing. That's a asphalt coated copper. Okay. This is interesting. This is a lot of form work that is needed to finish off the details with the floors of Catskill Hall. And the floors of Catskill Hall are hollow core planks. Any of you who have been in Catskill Hall. So there's the steel studs that you just saw from that first picture. And then eventually it'll get, the rest of those steel studs will be filled in, and then exterior grade sheetrock, and then brick, clay block and brick up the front. So here's the plan view, right? Kind of looking down at this area. Here's the plan view. So here's this little entrance area right here is right in here. Again, you can't see it over here. And there's 3 section views that you might want to look at before that next test, if you know what I mean. So section 2 is taken through the outside wall. Section 4 is taken through an interior block wall that has the hollow cores. See where it says 12-inch HC plank, hollow core plank. So the plank is supported from here to here. And then there's another plank from here to the wall that you can't see over here. Okay. And then section 5, I'm going to move this little bugger. Section 5 is here, which is a section through, say, a joint in the planks. Okay. So those are the 3 section views that you want to familiarize yourself with for this project. And here's section 2. Okay. So section 2, there's your hollow core plank. And there's 3.5-inch end bearing. So from the face of the block to 3.5-inch in, that's how much of the hollow core plank is bearing on an 8-inch block. I always thought that really was not a lot, but then again, I didn't design it. The SOAP course or form will show you what a SOAP course is. Actually, let's show you right now. Let's go to META. So again, META chapter 26. Chapter 26. So right here, there's your hollow core slab. It's very similar to Catskill, and that's the SOAP course, kind of like a cut block. Or you could use formwork because that block is not going to be exposed. It's going to have an air gap, and then it's going to have brick on the face of Catskill. Okay, so that's the SOAP course right there, which is what that's showing right there. Or the form, and we'll show you all the formwork that they did. So imagine that they came up to this course. This is an open web bond beam. It's got one number 5 running horizontal. It's got vertical dowels, number 4 continuous vertically, right? And UNO, unless noted otherwise. They grout the cell solid at the dowel, okay? From here all the way down. There is something called a grout stop. I'm surprised that that doesn't go all the way down. And the grout stop is, it's like a piece of mesh that goes in here that keeps the grout. If you want to say stop the grout, grout is in this core, this cell. You can put a mesh in there, and that might be, there it is. This plastic mesh is a grout stop right there. So this grout is only going to fill this one. And actually, it's the plastic mesh is where you have a vertical bar. The plastic mesh is cut out so that you can get grout, which is a concrete with a small aggregate size, all the way down to the cores. So I could take some details and I could point to different parts of these details, and I could ask you to identify the components. That's pretty much what I'm going to be after on the test. Plus some estimating, plus some specifications on CMUs. Okay. Here's a good shot. This is a small piece of steel that's used for an opening. Excuse me. So you can see right here is an open web bond beam. It's got that knockout. I don't know why they haven't knocked that out yet. And then they'll put another piece in here, and then they're going to grout that. And then there's the formwork. There's the formwork that they're going to put concrete between the end of this hollow core plank and the face of that formwork. And that's what you want to look at in MEDA chapter 26. See right there? Actually, it'd be this one. So there's going to get grout, concrete, to fill this gap from the end of the hollow core slab to where the soap course is, or the formwork that they used in Catskill Hall. Okay, and there's your hollow core slabs. Pretty damn heavy stuff. Is this stuff making sense going back and forth between the book and this? That's what you want to look for, okay? A lot of work in that doing that little form work. A lot of work. There's a good shot of everything. You can see just how busy they are, how much work there was, all that block and brick. These are the hollow core planks. Sections 4 and 5. Section 4 is where there's a interior block wall, and then you got a beam coming from this side and a hollow core plank, coming from that side. So you could say that right in here, you can't see it, but this hollow core stops here and runs this way. This hollow core here runs this way. So this would be section 4. Section 4 would be right here. Okay, so there's a block wall underneath. Section 5 is going to be a block wall, say, running this way. Okay, section 4 shows the block wall running this way. So if you do the slice like right in here, it makes sense that you can see the hollow cores. Okay. And again, there's your 3.5 inch of bearing. Not a lot, but what the hell do I know? And here's the hollow core planks being put into place. Again, think about all that work to put up that little formwork. There's our ET. I think everybody's asleep, including me. Okay, so here's a good shot where the hollow core planks, there's a gap that they're going to have to fill. Here's where they use a grout. It's a very high slump grout. Doesn't have big stone. Pea gravel, typically 1/4 to 3/8 inch. Right? Here's all the rebar that they got to grout in. There's that formwork that we were talking about. And that's where they've started to grout it in. And that's what ties in this building, if you will. So, you know, it stiffens the building once you grout all this in. And that's where they finish it off. So what goes on top of this? This is there's the first floor. This is the second floor. So what goes right here, folks?
CMUs.
Another height of block. Right? Shit, what did I do with that thing? Oh, watch my language. Shouldn't have said that. Right? So they, instead of this special cut block right there, they're going to grout that in because they got formwork. Once that's all ready to go, then you just start laying block for the next floor. We went through about a 10-year period where they built a lot of new buildings. It was a blast. Got to see a lot of good construction. But look at all the stuff that's got to go inside those cores, right? Because there's the dowels that are running continuous from the foundation all the way up through those blocks. There's your outlets and so on. Now, is that your finished floor in Catskill? I don't think I put that on the PowerPoint. Let's see if I can find it in my, we'll get to that in a minute. There's a good shot of all that formwork that needed to be done. Steel stud exterior, grade sheetrock, flashing. Okay. So let's insert new slide link, and let's insert pictures, and let's go to docs, and dorms, and Keegan pics. See these two pictures right here? This is your topping. Okay, so there's all your hollow core planks. Well, you don't want that as a finished surface. So what they do is they pour this. It's like a self-leveling grout. Sometimes I've heard it called levelastic, but that's more as a gypsum. That's done, you residential folks, they've done that before. They'll use a gypsum in residential buildings like apartment buildings to level the floor if their hollow core planks are the subfloor, if you will. So it's pretty interesting stuff. Now, one of the things that I think I wanted you to do, how did I put it? Yeah, and I'll redo this, but these are the pages out of the Meta book, chapter 26, that really give you good details of Catskill Hall. So you might want to take a peek at that. So, like I said, when we get you back in the fall, we'll do some mock-ups. They have not made their plans as to what we're going to do for the fall. I have a feeling they're just going to wait another month or two and see what goes on. So we'll get you doing a little block work next semester in commercial construction as well as the end of this course. So we've really covered now pretty much 2/3, and we're going to get into soils. And what we're going to do there is, here's a couple of YouTubes. These are kind of cool. This is like a 90-second mudslide in Norway. It was what's known as a marine clay. In other words, a clay near the ocean, if you will. Actually, I think it was the Baltic Sea up in Norway, or the North Sea. And it's interesting that it loses its stability very easily. You got to check this out. It is amazing. This soil strength is kind of cool. And then sieve testing is the first test that we're going to talk about in soils. But to give you an overall view of soils, you want to go to this website. Okay, this Wacker-Neuson. Wacker-Neuson makes compaction machines, and they have one hell of a, so there's that website that I was telling you about. And then at the bottom, it's the fundamentals of soil compaction. If you click on that, now it wouldn't show up, and it asked me if I wanted to run an older version of Adobe. So I said yes, and this is what you're going to get. Oh, come on. Don't do this to me. Well, it did work earlier. So if it does that, then you say allow. And hopefully this is interactive. Isn't that amazing? Isn't that amazing? So I want you to read the first, 13 pages. Very basic about soil compaction. It really does a nice job, okay? And they used to give an online quiz, but it's not there anymore. I was gonna have you take it, and regardless of what you got, in other words, you weren't gonna get 100 and you weren't gonna get a 0. I was gonna give you 20 points for doing it. So if you wanna send me a selfie with your mush right in front of, say, page 9, soil compaction, I'll give you 10 points, okay? I'll put that on Vanco. That'll be a 10 freebie. It snowed last night, so it's getting close to Christmas, so we'll throw a little Christmas present at you, okay? We're all going.
Did you give the bonus points for those of us that submitted on time with the homework?
I got to go reread that. I thought that was only if you lost points. Was it for this class or surveying?
Whatever that homework was that was supposed to be due Monday that you were given.
Well, tell you what, why don't you, I'm going to put this on you guys. Give me a screenshot from Vanco where I said that, and then I'll go back and give you the points. How's that sound?
Well, we talked about it in person.
How could we talk about it in person? We haven't, I think I put something on Vanco about that. You find that. I think that way it'll get you to read Vanco as to what the assignments are. Okay? But go ahead and read this. Get yourself a selfie with your face right next to this page, and we'll call that 10 points bonus. Okay? So in my spreadsheet, you would get 10 points, but it would not be adding 10 points to the total, to the possible total. So it's a 10-point bonus. So I'll put that in there. Okay. So if you read that, it really does a nice job. Okay. And it goes over some compaction, field testing, and then page 13 is where they get equipment types and selection. I'm not sure how much time we'll have to work on that, but if you folks get out there and you have to work in soil compaction, please, please, please give me a shout, and I'll help you. Because if all of a sudden they're asking about compaction and you say to them, well, where's your Proctor curves? I'll tell you what, that's where the cheese starts to bind. Their ears will perk up. Okay. So this is all about good compaction so you don't get differential settlement. Okay, vibratory plates, rollers, right? Sheep's foot rollers. So we're going to walk you through this whole soil process, but those first 13 pages do a really nice job on the general discussion of soil mechanics. Okay, so do that for Monday, and then I'll give you a little more soils information Monday night. We'll talk about the masonry test for next week, and then we'll roll into soils. So a week from tonight, we'll really start to talk about soil mechanics, soil compaction, soil classification. A lot of money. Okay. Any questions? So yeah, there's really no homework other than a free selfie. And I'll also look at Vanco and see what I was going to give you for a little bonus. But see if you can find it yourself. Do you have any questions on the surveying? Right here, the surveying tonight is part 3 of Burger King. This is what I have written down. Okay?
Mr. McKeegan, for the
What?
homework that's due in surveying on Sunday, is that strictly only page 3 to do, or do you want us to do the topo
Vanco,
stuff?
what's Vanco say?
Page 3, but I was confused with the lecture last week.
What's that say right there?
Page 3.
Thank you. Don't forget, I get chances to be grouchy. It makes me happy. Now, I got to tell you, don't send me an email saying you don't understand what's due. It's the same thing as walking past me in the hall. What am I going to tell you? What's on Vanco? Now, if you take a screenshot of Vanco and show me exactly where your question is, I'd be more than happy to help you. It's the same thing with any of this Burger King layout, right? But if you go to Vanco, and it's interesting, you know, I'm working this weekend doing some concrete work, and I was talking to my boss, and it was funny. I caught myself today because I was asking the same damn question over and over again. I could tell I was annoying him. That's why I'm trying to help you. It's not to bust your chops. So if you look at this, I sent you a news forum. Let's see what I wrote from, this was surveying, right? There's Burger King layout. Okay, so they've been posted. So that just says that those are the drop boxes. So let's go back, and then let's go back to this, and let's go find those drop boxes. So Burger King layout part 3. Okay, I've only got 13 submitted. What do you need? One more night? You want that due tomorrow night?
That would be lovely.
Okay. Jesus, I didn't hear one thank you. All I heard was that was to be lovely.
Yeah, please.
Much appreciated. Thank you.
Yeah, greatly
What about those
appreciated.
ones that already
Okay.
got it handed in?
Okay, I don't need 45 damn thank yous now. Just don't get syrupy. So that's going to be, let me get a pencil here. So that is BK Friday. If you've already handed it in, you're all set. And then what I told you up here, assume no obstructions at the site. All bullet items to be listed in your field book. So it better be in your field book. List the office, which is Civil 3D work items in prep for field work, right? Listen to the YouTube that I gave you. List the field work items as described on the handout. Again, listen to the YouTube. How are you going to lay out that Burger King knowing that the only horizontal control they gave you were dimensions that were 90 degrees from a property line? So you've got to tell me step by step how you're going to lay that out horizontally and try to visualize the work activities, okay? So a lot of times you just got to read this. And then if there's a certain thing that doesn't make sense, what were the Civil 3D work items? Right? The Civil 3D work items were literally plotting bearings and distances and converting that to coordinate geometry. So let's go to EDM identification. Complete page 5 of the handout. I'll be damned. There it is. Let's open it up, see what the hell page 5 is. Okay. There's 3, 4. That's all it is. Now you got a handout that actually shows what each of those components are. That's due Saturday. That's not going to change. Okay, I just want that page. I don't want the homework grouped in with one another. Okay? It's not making your boss's life easier. And then what was the last one? The last one was page 3. Enter all data and show a detailed, fully labeled field book entry for page 3 of the EDM Notes PDF handout. Let's go back to page 3. So there's your notebook. In other words, all of this data has to go in your notebook. All of this, I've already started it for you. This part right here, I've shown you where it's got to go in your notebook. Here's your sketch. Remember we talked about, I took that off because I didn't do a save, but there's the hand sketch that I was telling you about. Okay. And I think I had it in PowerPoint view. So when you go to Vanco, you got to read it. And that's how you're going to succeed in industry, where you are trying to stay one step ahead of your boss. And that is the key. That's where you're going to make some money. And that is due Sunday at midnight. So there's no reason why you can't get those 3 done. I'll give you till tomorrow on Burger King, and you should be in good shape. Okay? Did that help a little bit?
Yes, thank you very much.
So let me, what I'll do is I'll update everything. Ooh, I'm running out of batteries, so I better, I'm gonna stop the recording. This is the end of the Zoom for heavy civil and a little bit of surveying. Thursday, April 16th.